Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0192, refers to a low voltage condition in the fuel rail pressure sensor circuit in the Honda Pilot models from 2016 to 2022. This issue indicates that the engine control unit, ECU, is not receiving a sufficient voltage signal from the fuel rail pressure sensor, which is crucial for monitoring the fuel pressure in the fuel rail. The fuel rail pressure sensor measures the pressure of fuel in the rail and relays this information back to the engine control module, ECM. When the ECM detects that the signal voltage is below the expected threshold, it triggers the DTC P0192. This condition can lead to engine performance issues, as the engine may not be receiving the appropriate fuel pressure necessary for optimal operation. To effectively troubleshoot this DTC, a systematic approach is necessary, beginning with a thorough verification of the problem and using Honda's diagnostic tools like the HDS, Honda Diagnostic System. DTC P0192 indicates a low voltage condition in the fuel rail pressure sensor circuit. This sensor is part of the PGM-FI programmed fuel injection system, which manages fuel delivery to the engine for efficient combustion. The fuel rail pressure sensor is located on the fuel rail, typically found on the upper part of the engine near the intake manifold. Its role is to monitor the fuel pressure, sending this information to the engine control module, ECM, which adjusts the fuel injectors accordingly. If the voltage reading from this sensor falls below 0.31 volts, the ECM identifies this as a circuit fault, leading to the activation of DTC P0192. It's crucial to analyze both the current conditions and the freeze frame data, which captures vehicle parameters at the time the DTC was recorded, as this helps in understanding the context of the failure and streamlining the troubleshooting process. Several factors can lead to the activation of DTC P0192. Poor electrical connections, such as corroded or damaged wiring, can disrupt the signal between the fuel rail pressure sensor and the ECM. Loose terminals at the sensor or the ECM can create inconsistent voltage readings, potentially triggering this fault code. There may also be a shorted wire within the sensor circuit, causing the voltage signal to collapse. Open circuits, which can occur due to broken wires or disconnected connectors, can result in no voltage reaching the ECM, again, causing the P0192 code. Understanding these possible causes is critical in diagnosing and repairing the issue effectively. Reviewing wiring diagrams and pinout specifications for the sensor and connectors is beneficial during this process. When DTC P0192 is present, several performance-related symptoms may manifest in the vehicle. Engine performance issues may arise, such as rough idling or hesitation during acceleration, as the vehicle struggles to maintain the correct fuel pressure. Drivers may also notice a decline in fuel economy due to improper air-fuel mixture ratios caused by erroneous readings from the fuel rail pressure sensor. RPM fluctuations can occur, making the engine feel unstable or erratic. Additionally, if the fuel system is not receiving accurate pressure readings, it may lead to difficulties starting the engine, as the fuel delivery may not be adequately optimized. Recognizing these symptoms can provide further insight into the severity of the underlying problem before commencing diagnostic troubleshooting. The first step in troubleshooting DTC P0192 is to verify the problem by turning the vehicle ignition to the on mode without starting the engine. This should be done while waiting for about 2 seconds to allow the vehicle's systems to initialize. Next, using the HDS Honda Diagnostic System, the input voltage from the fuel rail pressure sensor must be checked. If the voltage readings indicate a value less than 0.31 volts, it confirms that the failure is duplicated, and you can proceed to the next troubleshooting step. If the voltage levels are above this threshold, it indicates an intermittent failure, suggesting that the system is functioning correctly at that moment. In such cases, it's essential to check for any potential poor connections or loose terminals associated with the fuel rail pressure sensor and the powertrain control module (PCM). This established initial check allows for efficient and accurate diagnostic progression. After confirming the low voltage condition in the first step, the next action is to determine the possible failure area. Begin by turning the vehicle ignition to the off lock mode. Once the vehicle is off, disconnect the fuel rail pressure sensor's 3P connector safely. After disconnecting, turn the vehicle ignition back to the on mode again to recheck the voltage parameter using the HDS. The goal is to measure the input voltage from the fuel rail pressure sensor to confirm it is still below the 0.31 volt threshold. If it remains under this value, it indicates a potential faulty circuit or sensor, allowing for progression to further testing. Conversely, if the voltage returns to an acceptable level, further checks on wire continuity and connections may be necessary. In troubleshooting step 3, start by turning the vehicle ignition to the off lock mode. Once the ignition is off, jump the SCS service check socket line with the HDS to set the system in diagnostic mode and wait for more than 1 minute. This step allows for accurate testing conditions. After the wait, disconnect PCM connector B51P to check for continuity effectively. The continuity test involves checking between two designated test points. Test point 1 at the fuel rail pressure sensor connector number 1, and test point 2 at a body ground reference. If continuity exists, it indicates a short circuit in the PF wire, and you should repair that wiring segment. If there is no continuity, it suggests that the PF wire is intact, and further investigation, possibly involving the use of a known good PCM or service information, is warranted. Moving on to step 4. The focus is to determine the possible failure area pertaining to the fuel rail pressure sensor itself. First, ensure that the vehicle is still in the on mode and the fuel rail pressure sensor's 3P connector remains disconnected for accurate voltage measurement. Measure the voltage between two specific test points during this operation, from terminal number 2 and terminal number 3 of the sensor connector. An acceptable reading here would show about 5.0 volts, which is the expected operating voltage for the fuel rail pressure sensor. If this voltage checks out correctly, the fuel rail pressure sensor may need to be replaced, signifying that the sensor itself is defective and not relaying proper signals. However, if the voltage reading does not meet the expected 5.0 volts, the process should proceed to the next troubleshooting step, where open wire checks will be performed. In the final troubleshooting step, again start by turning the vehicle ignition to the off lock mode, similar to earlier steps. Proceed to jump the SCS line with the HDS and allow more than 1 minute for the system to enter diagnostic mode. Following this, disconnect PCM connector C51P for the continuity check. The check will involve ensuring continuity between test point 1 at the fuel rail pressure sensor connector, 3 and test point 2 at PCM connector C51P number 32. This examination will help ascertain whether the VCC1 wire is indeed functioning correctly. A positive continuity test indicates that the wiring is intact, necessitating further consultation of service information or testing with another known operational PCM. If continuity fails, it confirms an open circuit in the VCC1 wire requiring repair to restore proper voltage to the sensor. After completing the required repairs for DTC P0192, it's imperative to conduct a final verification to ensure the issue has been resolved. Begin by checking the effectiveness of the repairs conducted. Use the HDS to clear any stored DTCs from the vehicle's memory to reset the system and verify that the repairs have been successful. After clearing the codes, it is crucial to perform a road test on the vehicle. During the road test, monitor the vehicle's performance closely while observing the live data to ensure that the fuel rail pressure sensor is relaying correct values to the ECM. If no new DTCs appear and the vehicle operates smoothly, it indicates that the repair was successful and that the issue has been addressed appropriately. To minimize the recurrence of DTC P0192 and ensure the longevity of the fuel rail pressure sensor circuit, implementing a preventive maintenance strategy is vital. Regularly checking electrical connections and terminals associated with the fuel rail pressure sensor can help detect any potential issues before they escalate into faults. In addition to visual inspections, be sure to check the wiring harness for any signs of wear, fraying, or damage that may compromise electrical integrity. Periodically monitoring fuel system performance is also essential, including observing any changes in engine behavior, such as performance dips or unusual fuel consumption rates. Performing these maintenance tasks will facilitate early intervention and contribute to the overall reliability of the vehicle. In conclusion, understanding DTC P0192, which indicates a low voltage in the fuel rail pressure sensor circuit, is essential for maintaining proper vehicle performance. The fuel rail pressure sensor plays a critical role in accurately measuring fuel pressure, allowing the engine control module to optimize fuel delivery. A systematic troubleshooting approach, as outlined in previous slides, ensures that technicians can identify and rectify the source of the issue effectively. From verifying the problem to conducting thorough tests, each step is designed to pinpoint potential faults accurately. Additionally, preventive maintenance practices must be adhered to in order to mitigate future occurrences and enhance the vehicle's reliability. Overall, addressing DTC P0192 promptly helps in preserving engine performance and efficiency, making it crucial for any Honda Pilot owner or technician. Please like and subscribe to the channel. See you next time.